all the videos up to now, I've shown you that when given a function, any function, as long as it must be a function, when given any function here, we can apply these transformations. And just recently, I've shown you these two transformations here. So whenever you get this here, if you have a function, I don't know, something like this, this transformation here is really a reflection along the y-axis. So what goes along here? Let's say equals 2 here. What goes along here would be u. So this is minus 2. You are stealing this point and moving it over to here. What goes along the minus 2 here is, well, you've got to look at positive 2. So this point here gets moved to over here, and then what goes along minus 3 here is you looking at f of 3, positive 3, which is, let's say, here. So that gets moved to over here. So the two sides switch around. So if you have a function like this, this side will move over to here. This point here will get moved over to here. Basically, they switch over, giving you the illusion that it's, well, it's not an illusion, giving you the impression that it's a reflection along the y-axis. So whenever you get this transformation here, it's really a reflection along the y-axis. And whenever you get this transformation, it's a reflection along the x-axis. So if you have a graph like this point here will get moved up to here, and then this point here will get moved to down here. So this transformation here is a reflection along the x-axis. This transformation here is a reflection along the y-axis. Now, in this video, we're going to look closely at this one here. Whenever you get a function, any function, let's say f of x here, whenever you get given this function, any function, if you apply this transformation, okay, after applying this transformation, hang on. So given any function, if after you applying this reflection here, if after you're applying this transformation here, it also equals the original function, then you can say that this function here is an even function. Okay, this will make sense later on when you see some examples. So whenever given a function, whenever given any function here, if after you applying this transformation here, if after applying that transformation it also equals the original function, then this function here is known as an even function. So let me give you an example. Let's look at y equals y. No, not y. Let's look at f of x equals x squared. Now this line here, this quadratic here, is x squared. Now, if looking at 2, now we've been given a function here. Let's apply the transformation where we have f of minus x here. Okay. So what goes along when x equals 2 here? Well, if you put 2 into here, it's really you stealing the point of f of minus 2. Well, this is minus 2 here, f of minus 2 is here. So this point here will get moved to over here. Now, if you look at minus 2, if you look at minus 2, if you put minus 2 into this bit here, it's really you. So it's really you working out f of positive 2. So it's you stealing this point here, f of positive 2. Well, positive 2 is here, so this point here will get moved to over here. So they switch around, but they're exactly the same. If you look at, so basically, at the moment we've got a function f of x here equals x squared. When you apply this transformation, it will be exactly the same, because this point here, well, this point here gets moved to over here, and then this point here gets moved to over here. They're exactly the same. If you look at 3 squared is 9. Let's say 9 is here. And then if you look at minus 3 squared is also 9. You see, starting out at this original function here, when f of 3 is 9. So when you apply this transformation, it's you stealing f of minus 3. So this point here gets moved to here. If you look at minus 3, then it's you working out f of positive 3. So this point here gets moved to over here. So basically, when you get given this quadratic here, when you reflect it along the y-axis, it will be exactly the same. So when given a function here, f of x equals x squared here. Now let's apply this transformation now, f of minus x. Now it's used putting this minus x into here. So it would be this. It would be this. So it's you putting this minus x into this thing here. So at the moment we've got something squared. Now we're going to put minus x into this x here. So it's going to be like this. Okay. So now this function here. Hang on. So we've got minus x times minus x. So it's minus x times minus x. So let's just get x times x. That's normal. That's x squared. And then now two negatives. That makes a positive. So you've got this. So basically, it's this. Can you see? This was our original function here. This is us applying the reflection here. So that equals this. But this turns out to be this. And look at this. After applying the reflection here, our new equation is also this. So here, well, originally we started with f of x here. F of x equals x squared. After applying the transformation, it also equals x squared. So we can say here, that f of x here equals f of minus x. Because this is true here, then we can say that f of x is an even function. Okay, let me give you another one here. Let me give you another example. So take this function here. So it's really a quadratic here, and then because it's plus 5, you moving it up 5. So at the moment we've got f of x equals this thing here. Now let's apply the transformation. Let's apply the transformation of f of minus x here. So we've got to put this minus x into where there is an x. So that equals is, at the moment we've got x squared plus 5. So because we are putting, well, we've got to put the minus x into here. And if you look at this here, this then becomes x squared, because minus x times minus x is x squared. And this 5 stays the same. So you see, after applying this reflection here, it's the same as the original. Now that we know that f, hang on. Now that we know f, why isn't my pen isn't working? Okay, sorry. Now that we know f of minus x here equals f of x, because we know this is true, then we can say that f of x is an even number, is an even function. Because if you look at this here, if you look at this point will get moved over to here. This point here will get moved over to here. If you look at this point here gets moved over to here, and it would be exactly the same. So you know that this here is an even function. Okay.